Good morning. So today we are going to practice solving one-step equations with addition and subtraction. So solving one-step equations with addition and subtraction. That's our learning target for today. Okay, so in my last video, you may have seen me write something like this, and this was just my little way of drawing a balance beam. So here's the center, and each side might weigh something differently, but we're trying to solve equations to put whatever on one side that equals the same amount on the other. So if I were to, put an orange ball on the left side, a nice big one, and I have, 3 green cubes that I put on the left side, and then I have 7 green cubes on the right side. I need to figure out how much this orange ball weighs. So I'm going to show you what my drawing represents as an actual mathematical algebraic equation. Okay, so I don't know what my orange ball weighs, so I'm going to use the letter X to represent that. And if I add these 3 boxes to it, assuming that each box weighs, 1 pound or 1 unit, I know that whatever that orange one is plus those 3 units equals 7 units. Okay, each side is balanced, so I have to figure out what that unknown piece of information is. Now, some of you are able to do this mentally and say, oh, I know what that orange ball weighs. However, we are going to start laying the foundational skills to solving algebraic equations, because these equations are going to get way more complex. So I'm going to give you some resources and some helpful tips and tricks over the next couple days and over the next few weeks that are going to help you solve what X actually is. The first term I want to present to you is the word inverse. Okay? And inverse operations actually reverse whatever the first operation was. So it reverses the effect of the first operation. It gets us back to where we started. So if I start with X and I add 3 to it, okay, whatever X is, if I want to get back to X, I need to use the inverse operation. So the inverse operation to addition is subtraction. Okay, the inverse operation to subtraction is addition. The inverse operation to multiplication is division, and the inverse operation to division is multiplication. That's how we undo those operations. Okay, there's lots of other inverse operations like square roots and squaring units and squaring terms. So lots of options, but I'm just going to start with those basic skills for right now. Okay. So when I talk about inverse operations, that means I'm going to take away 3 units, so I just have the orange ball left. Okay, so I'm going to take those 3, whatever they are, whether they're pounds, or I'll say pounds for the example. So if that's 3 pounds, I'm going to take off those 3 pound weights. But then this is going to weigh more. Okay, so I'm going to also take off 3 from this side. So then I only have 4 left over here. And that's going to even out the balance beam. Okay, so I took 3 off over here. I'm going to take 3 off over here. And what that looks like in mathematical terms would be to subtract 3 here and subtract 3 here. And we know if we add 3 and then subtract 3, we're just left with X. Okay, so that's on one side of the equation. And then if I take 7 and I subtract 3, I'm left with 4. So X equals 4 in this case, or the orange ball equals 4 pounds. Okay, so let's do a few examples here with solving one-step equations with addition and subtraction. Okay, so I have another example here, and I am going to draw my balance beam to show you, and I'm going to draw my model so you can see the relationship between my model and my mathematical equation. So if I have the equation n plus 5 equals 10, I'm lining it up so that one side of the equation has n plus 5, or one side of the balance beam has n plus 5 and one side has 10. Okay, so I'm going to use the same colors and the same images. I'm using the orange ball to represent the unknown information, and I'm using little cubes to represent the numerical values. And I'm going to draw 10 over here. I'm just going to draw 5 on top of each other twice. Okay, so in order to figure out what n is, I need n alone, so I have to undo everything that's around it. Okay, so I am going to leave n be, and I'm going to take away 5. Okay, that's the same thing as taking off these weights from this side of the equation. But this side's going to, once I take those off, this side's going to weigh more. Okay, so I have to go back and balance it by doing the same thing to that side and take off 5 weights from over there. So now I'm left with just the orange ball, which is n, and then I'm left with 5 units over here. So n equals 5. Okay, that is my final answer. But the really nice thing about algebra is that you can actually go back and triple, double check, quadruple check your work, because now I know what n equals. So if I were to plug in n equals 5 in this original equation, okay, and I add 5 to it, would I get 10? 5 plus 5 equals 10. Yes, that checks out, so those are balanced. If I had gotten a number such as, 17, if I plugged 17 in plus 5, that doesn't get me 10. So that right away tells me, oh, wait a minute, I need to go back and I need to resolve and recheck my math. That's a really cool thing about algebra. So sometimes just double checking to see if a number is a solution to an equation. So another vocabulary term for you is that a solution of an equation is a value that makes the equation true. So 5 is a solution because it makes that equation up here a true statement. Okay. Now let's give you an example and let's check one out here. Okay. I'm going to give you the equation p plus 10 equals 38. If p equals 18, is that a solution to this equation? So let's plug it in. Let's plug in p equals 18. Just like when we used to substitute with expressions, we're going to substitute with equations. So I'm going to plug in the 18. I'm going to do this step by step, and I'm not going to skip any hoops or make any shortcuts because I really want to confirm my thinking. And 18 plus 10, solving the order of operations, there's only one operation. So 18 plus 10 is 28. 28 does not equal 38. So that is not a solution. Is not a solution. Okay. Okay, so first I'm going to give you some equations with some variables that have a set value, and let's see if they're solutions. Okay, so I have example here, I have x plus 42 equals 85. Is x equals 43 a solution or not? Okay, so what's going to happen is I'm going to take this x and I'm going to replace it with 43. Okay, so I'm going to take that x and replace it with 43. I'm literally going to take it out, replace it, and I'm writing my equation. So remember, back a couple of months ago, we would rewrite the equation, substitute, and simplify. All right, so those were our awesome tips and tricks to help us remember. Rewrite the equation, substitute, simplify. So our next step is to actually add these two numbers. You could take out a calculator, or you can write them on the side, adding up the place value. Okay, and 85 is equal to 85, so that checks out. That is a solution. Woohoo! Okay. Now, I'm going to give you another example here. Let's do a subtraction example. So 18 equals y minus 4. And does y equal 12? Okay. Some of you may be doing this in your head, but I want to make sure that you take the time to rewrite the equation, substitute, and simplify. I'm going to rewrite. I rewrote the equation here. I'm going to substitute the 12 for y, and I'm going to subtract 4. When I do 12 minus 4, I get 8, and that does not equal 18, so it is not a solution. And that's our final answer for that one. Same goes for one-step equations with multiplication and division. Okay, if I were to give you m divided by 4 equals 16, does m equal 4? Okay, is that a solution? So if I plug in m equals 4 and replace the m with 4, 4 divided by 4, does that equal 16? 4 divided by 4 equals 1, and that does not equal 16. So you can put an X or a line through the equal sign. So that is not a solution. Now you may be asked to actually figure out what are solutions to make these equations true. Okay, what are the values of the variables that you don't quite know yet? So let's go through a couple of examples with one-step equations using addition and subtraction. Okay, so I'm going to use v plus 9 equals 18. Thinking back to our balanced equation, if I just want the variable by itself, I'm going to undo everything around it. So I'm going to subtract 9. Okay, undo means to use the inverse operation. The inverse to addition is subtraction. What you do on one side is the same that you do on the other, right? Because you want everything to be balanced. So if you take off weights on one side, you have to take them off on the other. Then I'm going to end up with v equals 9. I could record my work and say if I'm at 9 and I take away 9, I end up at 0. That is not necessary, okay? 0 does not change the value of anything, right? Our additive property tells us that adding 0 does not change the value of v. So I could just say v equals 9, okay? Last step that we want to do is just plug 9 back in to make sure that 9 is a solution. So 9 plus 9 equals 18. 18 equals 18. That is a balanced equation, so I'm good to go. And one last example here. I have 8 equals r minus 14. I want r by itself. That's what I'm trying to find. So I'm going to undo what's happening here, which is subtracting 14. The inverse operation to subtraction is addition. Okay. And whatever I do to one side, in this case, I'm adding weights to the side to get back to r. So I need to add weights to that side. And 8 plus 14 is 22. And when we subtracted 14, we added 14 to get us back to r. We're left with r. 22 is our final value of r. Let's double check. Rewriting, substituting, and it's super important that we keep our order than what's in our original problem. and 8 equals whatever 22 minus 14 is, which is 8. That checks out. So it is a solution. So go ahead and let's get practicing our one-step equations with addition and subtraction, and let us know if you have any questions.